The same story as the previous examples. As you can see, again, collection of data. For example, a statistician may collect data on the blood pressure of 50 patients who all use the same blood pressure medication to come up with a range of values that is likely to contain the true mean reduction in blood pressure for patients in the overall population who use this particular medication. So here, for example, it says that with 90%, there is a chance of 90% that the reduction in blood pressure is in this range, for example. Okay, after reviewing these three main tasks in statistics, that there is a good chance that you already have read them in one statistic class that you have had. Let's check again statisticians versus data analysts. In the previous one, we had field of statistics versus field of data analytics, and here we have statisticians versus data analysts. Both statisticians and analysts work with data. That's undeniable in their daily roles, but statisticians tend to be more focused on testing a statistical hypothesis. Now, my friends, I showed this to you with examples. That was the reason we reviewed together that three functions, important functions in statistics, and you noticed how much the things that we are dealing with in statistics are not certain, so it goes to test hypotheses, but analysts tend to be more focused on understanding data and patterns underlying business operations. So you see again, it offers that data analytics, it doesn't care about the theoretical points, the scientific mathematical points. It just wants to understand data. Now you are learning it with statistics, now you are learning it with artificial intelligence or any other science that we have. They care about understanding data and patterns underlying business operations, because in that situation, it makes it possible for better decision making. Okay, we have come up with the conclusion that we discuss it together, that statistics is some sort of offering tools to data analysts to understand data better, to understand the patterns behind data better, to be able to make better decisions. What were the things that we did together? We talked about some purely mathematical things like hypothesis testing, like ANOVA, like confidence intervals, and all those things. But I want to tell you, it is not, for example, when we talk about statistics is all about these mathematical things. No, we have descriptive statistics that is now completely in the same way being used by data analyticians, and in a way that now in data analytics we have a category that is called descriptive analytics, that is the same as descriptive statistics. In business analysts, that is some sort of data analytics, often use descriptive statistics to summarize data related to the finances of companies. Okay, my friends, so here when it says business analysts use descriptive statistics, it means that exactly the same thing that are discussed here being used by them. But when they use them, they are in fact doing a particular category of analysis that is called descriptive analysis. It is one of the 4 major parts of data analytics. For example, a business analyst, again, consider it as a descriptive data analyst who works for a retail company may calculate the following descriptive statistic during one business quarter. Mean number of daily sales? Yes, that's data analytics. A standard deviation of daily sale? That's data analytics. Percentage change in new customers, and like that. Using these metrics, the analyst can gain an understanding of financial state of the company. So you see, then it helps with understanding data so they can make better decisions, especially when they discover the trend over time. They can then use these metrics to inform the organization on areas that could use improvement to help the company increases revenue or reduce expenses. So I wanted to have this slide here to notice that it is not only about those things that whenever we say statistics, it created some sort of disgravity. Okay, there are some part of statistics that are in fact data analytics, because they directly being used for giving insight about data. Descriptive analytics is very close now to this skill, data visualization. Data visualization is now that much popular that some people put it on their CVs as their skills. Now we have hiring flyers in the market that they just look for people who are expert in data visualization. Analysts, and it's of course data analytics. Analysts who work for retail companies often created data visualizations such as line charts, bar charts, heat maps, box plots, scatter plots, and other charts to visualize the total sale, revenue, expenses, refunds, etc. during different business quarters. So what is this? It is some sort of descriptive statistics. It is some sort of descriptive data analytics that is called data visualization. Now you see, we are talking about the parts that are very common, that have overlap between data analytics and statistics. But we have some people in the field of data analytics that they use this descriptive analytics and they believe it is data analytics, and we have some statisticians that they use descriptive statisticians and they believe. You remember, for when we were in the hypothesis, for example, test or ANOVA, I told you they are absolutely statistics. But these things that now we are checking together, they are using in both of them with different names. In real world, many analysts often create interactive dashboards using softwares like Tableau so that business leaders can interactively dig into different metrics and explore data trends and patterns to better understand how the business is performing. Now, my friends, this art that you are seeing here, this, for example, creating these interactive dashboards to be able to have a better understanding, this is absolutely in the field of data analytics. It is not statistics. Statistics is science. It is just pure science. About application, it depends on the people who are using them. But when a person comes and use that idea of statistics and create interactive dashboards to, for example, quickly change some of the parameters and see the results, it is data analytics, because you are in fact trying your best to have a better understanding of the data, the patterns, to be able to make better decision making. And that is the reason, as I told you before in another video, we are trying our best to add this software to your curriculum. And it would be there hopefully from next semester in one of the courses that you are taking. And if we couldn't do that, it goes for next year. So it is that point about data visualization, and especially you see the point that make the part that is related to data analytics different from statistics is that leverage type of software that for example, you change something and you immediately see the result somewhere else. So of course it is data analytics, because they are trying to make the best understanding that is originally used to be a statistic, for example, to draw a bar chart, but now when it comes to interactive type of things and all those things, it becomes in the field of data analytics. And that's the reason, again, the people who think they have a very good mind regarding business decisions, data analytics is a very good field for them, because this field is about intelligence in using different methods in other sciences, artificial intelligence, statistics, and some of the techniques that are originally and absolutely belong to data analytics to make the best decisions. And lastly, the things that we are gonna see here together is regression models. Regression models, mostly we know them as predictive models. And here we have an example, and regression model, again, some of those things that we see in statistics, but in data analytics also it is considered as of the main models. But originally for many years, many years, it has been discussed in statistics classes. And but why now it is this much being used in data analytics? Because they are about prediction. And when you, even in understanding the data, for example, here it says financial analysts often use regression model. So you see, my friends, financial analyst. It doesn't say data analysts, financial analysts. So it is absolutely in the field of business analytics. Often use regression model in statistics. We know that data analysts use statistical models to make decisions, to quantify the relationship between one or more predictor variable and a response variable. What is predictor variable? Predictor variable could be price of oil. And what is response variable? For example, price of gold. When you can find a relation between price of gold and price of oil, it is called a regression model. We can have many predictor variables, 1, 2, 3, 4, but here a simple one is shown to you. And here X is the predictor and Y is the response one. And here with statistical techniques, they are able to draw this line as the best alignment among all these points that are real data, and they come up to these results that as you can see here, using this model, a financial analyst can quickly understand that money spent on online advertising results in much higher average revenue compared to money spent on TV advertising, because here it says revenue is a function of online advertising and TV advertising. But as you can see, TV advertising generates $0.8 for the advertise that's being done here, plus this, and online advertising is 4.6. So just by looking at this, of course, we are now willing to spend more money on online advertising. And that's it, data analytics.